August 7th, 1944. Oberfeldwebel Hans Zimmermann sat inside Tiger number 214, hull down, behind a hedgerow 3 kilometers east of Mortain, watching American Sherman tanks maneuver in the valley below. His crew had been in combat for 11 days straight. They'd knocked out 6 Shermans, 2 tank destroyers, and countless vehicles. The Tiger had taken hits, certainly dozens of them, but nothing had penetrated. Nothing could penetrate. That's what they'd been taught. Then the first white phosphorus round struck the turret side. Zimmermann saw it coming, watched the red tracer arc through the morning haze and impact just below the commander's cupola. The explosion was different from the armor-piercing rounds they'd grown accustomed to. This one bloomed outward in a spectacular cascade of white smoke and burning particles. Within seconds, thick white smoke engulfed the tank. The ventilation fans, designed to clear cordite smoke from the fighting compartment, did what they were designed to do. They pulled the phosphorus-laden smoke inside. The heat was immediate and suffocating, but worse was what Zimmermann couldn't see. Through his vision blocks, the world had vanished into white opacity. His loader started coughing. His gunner reported he couldn't acquire targets. The driver said he couldn't see the road. And then, through the smoke, swirling outside, another Sherman round struck the engine deck. This time, something caught fire. The Americans had been facing Tiger tanks since Tunisia in early 1943. For over a year, they'd watched their 75mm shells bounce off Tiger armor at ranges where the Tiger's 88mm gun could destroy them with impunity. The mathematics were brutal and undeniable. A Tiger could kill a Sherman from 2,000 meters. A Sherman with the standard 75mm gun needed to close to within 300 meters, preferably less, to have any chance of penetrating a Tiger's side armor. The frontal armor was essentially invulnerable. This disparity created a psychological weapon as potent as the Tiger's gun. American tankers developed what some commanders called Tiger terror, a paralyzing awareness that you were outmatched, outgunned, and likely to die if you encountered one of these 60-ton monsters. Intelligence reports from Tunisia describe Tigers shrugging off multiple direct hits at point-blank range. In one engagement, 8 rounds from a 75mm gun bounced off a Tiger's side armor from just 45 meters away. British Churchill tanks, armed with 6-pounder guns, watched their shells ricochet harmlessly off Tiger armor while German crews traversed their turrets and methodically destroyed each attacker. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The German propaganda machine amplified the Tiger's reputation. Newsreels showed Tigers crushing enemy tanks, their thick armor impervious to enemy fire. Tank aces like Michael Wittmann became household names in Germany. Wittmann himself claimed 138 tank kills, many while commanding a Tiger. His most famous engagement at Villers-Bocage in June 1944 saw him destroy up to 14 tanks and 15 personnel carriers in 15 minutes before his Tiger was finally disabled. But propaganda and battlefield reality are different things. What the newsreels didn't show was what American tankers were discovering through brutal trial and error. The Tiger was powerful, certainly, but it wasn't invincible. It had vulnerabilities, mechanical and tactical. The question was how to exploit them without getting killed in the process. The American solution began with doctrine. Unlike the Germans, who designed the Tiger specifically to fight enemy tanks, American doctrine separated these roles. Tanks were for exploitation and infantry support. Tank destroyers were for killing enemy armor. This meant that when Sherman crews encountered Tigers, they weren't supposed to engage directly. They were supposed to call in tank destroyers equipped with higher velocity guns or withdraw and let the anti-tank units handle it. In practice, battles don't work that way. Engagements happened suddenly at close range, in terrain where withdrawal meant death. Sherman crews found themselves face to face with Tigers whether doctrine permitted it or not. So they developed tactics, improvised from necessity, refined through survival. The first tactic was simple arithmetic. Tigers were rare. Germany produced only 1,347 Tiger Ones between August 1942 and August 1944. They were deployed in independent heavy tank battalions, usually with 45 Tigers per battalion, attached to corps or army-level commands. This meant that most German armor American tankers encountered were Panzer IVs or Panthers, formidable but not invulnerable. When a Tiger appeared, it was usually alone or with one or two others, never in the numbers that made up panzer divisions. American tankers learned to use numbers. A single Sherman couldn't kill a Tiger from the front, but 5 Shermans, working together, could. Standard tactics evolved quickly. When encountering a Tiger, one section of 2 or 3 tanks would engage frontally, drawing fire and attention. The Tiger's gun could only aim at one target at a time. Its turret traversed slowly compared to a Sherman's. While the Tiger engaged the frontal section, the other Shermans would flank, maneuvering through terrain, using buildings or hedgerows for cover, working around to hit the Tiger from the side or rear where its armor was thinner. This cost lives. The flanking tanks usually made it. The tanks drawing fire often didn't. But the mathematics worked. American tank units accepted loss ratios that would have been unthinkable to German commanders. By some estimates, American tankers lost 3 or 4 Shermans for every Tiger destroyed. But America could afford those losses. Germany couldn't. The second tactic was more technical. In January 1944, the Army began fielding Shermans equipped with a new 76mm gun. This weapon had better armor penetration than the original 75mm gun, though it still couldn't reliably penetrate a Tiger's frontal armor. More importantly, by mid-1944, limited quantities of high-velocity armor-piercing ammunition began reaching frontline units. These tungsten carbide cord rounds could penetrate the Tiger's frontal turret at typical combat ranges, but HVAP rounds were scarce. The tungsten carbide required for their manufacture was in short supply, needed for machine tools and other war production. Tank crews rarely had more than a handful of HVAP rounds. Most went to tank destroyer battalions. Sherman crews had to make do with standard ammunition for most engagements. This is where the white phosphorus round entered the calculation. The M64 white phosphorus smoke round was never designed as an anti-tank weapon. It was artillery spotting ammunition, intended to mark targets with smoke so that indirect fire could be adjusted. The round contained white phosphorus mixed with felt soaked in rubber solution, all packed into a standard 75mm shell casing. Upon impact, the shell burst, scattering burning phosphorus particles that immediately ignited upon contact with air, creating a dense white smoke screen. Phosphorus burns at temperatures between 800 and 1500 degrees Celsius. It burns on contact with oxygen and continues burning until consumed or until oxygen is cut off. It sticks to surfaces. It produces smoke so thick that visibility drops to near zero within seconds, and it cannot be extinguished with water. Water only spreads phosphorus particles and makes the burning worse. American tank crews discovered that the M64 round had several unintended effects when fired directly at German armor. First, even though the round couldn't penetrate armor, the impact shock on the tank's exterior was substantial. The explosion scattered burning phosphorus particles across the tank's surface, sticking to vision blocks, periscopes, hatches, and ventilation grills. Second, the smoke production was so intense and immediate that it effectively blinded the German crew. Tiger tanks depended on their excellent Zeiss optics for their long-range advantage. When phosphorus smoke engulfed a Tiger, those optics became useless. The commander couldn't see to direct fire, the gunner couldn't acquire targets, the driver couldn't navigate. Third, and most critically, the burning phosphorus created a secondary effect that American tankers hadn't anticipated but quickly learned to exploit. Tiger tanks, like all German armor, were equipped with ventilation fans to clear gun smoke from the fighting compartment after firing. These fans pulled in outside air. When white phosphorus smoke surrounded a tank, the ventilation system pulled that smoke inside. The effect was suffocating and terrifying. The crew compartment, filled with thick white smoke that burned eyes and lungs. Visibility inside the tank dropped to zero. The temperature climbed rapidly. Crew members couldn't see their instruments. They couldn't see each other. The natural human response to being inside a smoke-filled metal box is panic. But there was something else, something American tank crews noticed but didn't fully understand until after the war. Tigers were burning. Not immediately, not from the phosphorus round itself, but minutes later. Tank crews would fire white phosphorus at a tiger, the smoke would engulf it, and then, often while they were maneuvering for a flank shot, the tiger would erupt in flames. Real flames, not just phosphorus smoke, internal fires that consumed the tank from within. Lieutenant Robert Early, commanding a Sherman platoon in the 2nd Armored Division, reported engaging a tiger near St. Lo. In July 1944, his gunner fired 2 white phosphorus rounds at the tiger, both impacting the turret side. The tiger didn't penetrate, didn't disable the tiger mechanically, but within 2 minutes, smoke began pouring from the tiger's engine deck, followed by flames. The German crew bailed out. Yet when Early's platoon moved up to secure the burning hulk, they found the tiger's exterior largely undamaged. Whatever had caused the fire had started inside. Similar reports came from multiple units, white phosphorus rounds that didn't penetrate armor, somehow causing tigers to burn from the inside. American tankers developed theories. Maybe the phosphorus was finding its way through ventilation ports. Maybe it was igniting fuel vapors. Maybe it was some peculiarity of German tank design they didn't understand. The theories led to doctrine. By late summer 1944, tank platoons were deliberately carrying white phosphorus ammunition as part of their standard load, not for smokescreens, as anti-tank ammunition. The official designation was still smoke round, but everyone knew what it really was. It was the round you fired when you couldn't penetrate the armor. Commanders began incorporating phosphorus into standard anti-tank tactics. When engaging a tiger, the first round fired would be white phosphorus. Blind the target, fill it with smoke, see if you get lucky and it catches fire. While the tiger's crew dealt with the smoke, the remaining Shermans would maneuver for flank shots with armor-piercing rounds. This approach had the additional psychological advantage of turning the tiger's own strengths against it. The thick armor that made the tiger invulnerable also made it a sealed box. When that box filled with smoke, the crew had 2 choices: abandon the tank or suffer. German training emphasized fighting from inside the tank, never abandoning a functioning vehicle. But training doesn't account for the human response to suffocation. American after-action reports from the Battle of Normandy and the subsequent campaign across France note increasing instances of German crews abandoning tigers that appeared mechanically functional. The tanks would be engaged with white phosphorus engulfed in smoke, and the crew would bail out before any armor-piercing rounds were fired. Post-battle examination of these abandoned tigers often showed minimal actual damage: turret rings jammed by shell impacts, vision blocks obscured by phosphorus residue, but the tanks were otherwise operational. The Germans noticed this too. Unit commanders reported with frustration that experienced tiger crews were abandoning their tanks after taking what should have been non-threatening hits. The 504th Heavy Panzer Battalion's War Diary for late July 1944 notes that the crew of Tiger 131 abandoned their vehicle after what the diary dismissively describes as 2 harmless hits from a Churchill tank. Investigation showed the hits were far from harmless, one jamming the turret ring and effectively preventing the tiger from fighting, but the tone suggests frustration at what German commanders saw as premature abandonment. What the German commanders didn't understand, what they couldn't see from outside the tank, was what those hits did to the crew inside. The shock of impact, the immediate smoke, the temperature rise, the inability to see or breathe, and worst of all, the awareness that American tanks were still out there, positioning for another shot, and you were blind inside a metal coffin. By August 1944, the pattern was clear to American tank crews. White phosphorus worked. Not always, not reliably, but often enough that it became standard practice. Fire white phosphorus first. If the Tiger burns, excellent. If the crew bails out, excellent. If neither happens, at least you've bought time to maneuver. What American tankers didn't know, what they wouldn't learn until captured German technical documents were translated after the war, was why the Tigers were burning. The answer wasn't in American tactics, it was in German engineering. The Tiger tank was a masterpiece of armored design in many ways. Its armor was among the thickest fielded by any nation during the war. Its 88mm gun was arguably the best tank gun of the conflict. Its Maybach engine, when working properly, provided adequate power despite the tank's enormous 60-ton weight. But the Tiger was also a product of German military priorities that created specific vulnerabilities that American phosphorus tactics exploited almost by accident. First, the Tiger's ammunition storage. Unlike American tanks, which stored ammunition in protected bins with blowout panels, the Tiger stored most of its 88mm rounds in unprotected racks along both sides of the hull, 92 rounds total capacity, with ammunition stacked in racks directly next to the fuel tanks. This meant that any penetration of the side armor had a high probability of hitting ammunition, and any fuel fire would immediately threaten ammunition storage. Second, the Tiger's fuel system. The tank carried 540 liters of fuel split between multiple tanks positioned in the rear of the hull. These tanks were protected by the Tiger's side armor, which ranged from 80 to 100 millimeters thick, depending on location. But the fuel lines, the pipes connecting the tanks to the engine, ran along the inside of the hull, unprotected. Third, and most critically, the Tiger's ventilation and engine cooling system. The Maybach HL-230 engine generated enormous heat. Keeping it cool required substantial airflow, which was provided by radiator fans that pulled air through grills on the engine deck, through the engine compartment, and exhausted it out the rear. This system worked efficiently, but it created a pneumatic connection between the exterior of the tank and the interior spaces. When white phosphorus smoke surrounded a Tiger, the ventilation fans pulled that smoke through the engine compartment. The smoke itself wasn't the problem. The problem was that phosphorus particles, still burning, were small enough to pass through the radiator grills. These particles would settle on hot engine components, on fuel lines, on electrical wiring. And phosphorus, remember, burns on contact with oxygen. It burns until it's consumed or until oxygen is cut off. A single phosphorus particle landing on a fuel line could ignite fuel vapors. A particle landing on oil-soaked engine components could start a fire that spread through the engine compartment. And once a fire started in the engine space, it was almost impossible to extinguish from inside the tank. The Tiger's fire suppression system was minimal, designed primarily to deal with electrical fires, not chemical fires. The crew had handheld extinguishers, but these were useless against phosphorus. Water made it worse. The only way to fight a phosphorus-fed engine fire was to stop the ventilation fans, cutting off oxygen flow, but doing so meant the engine would overheat and seize within minutes. This created an impossible choice for Tiger crews. Keep the fans running and risk fire spreading through the engine compartment, stop the fans and guarantee engine failure. Either way, the tank was dying. American tankers firing white phosphorus rounds didn't know any of this. They didn't know about the unprotected fuel lines, or the ventilation system design, or the ammunition storage layout. They just knew that white phosphorus made Tigers burn, and burning Tigers were dead Tigers. The Germans knew, or at least their engineers knew, but this information never reached the tactical level. Tank crew training manuals said nothing about phosphorus vulnerability. Commanders weren't briefed on the specific risks. The assumption was that the Tiger's armor would protect the crew from everything. So what happened if that armor was bypassed through ventilation systems wasn't considered. This information gap had consequences. Tiger crews continued fighting by the manual, keeping ventilation fans running during combat, maintaining engine cooling, doing everything they'd been trained to do. And when American tanks fired white phosphorus rounds, Those crews died or abandoned their tanks or burned without understanding why. By September 1944, American intelligence officers began noticing something in their interrogations of captured German tankers. When asked about Tiger losses, the prisoners would mention fires, internal fires, inexplicable fires, fires that started after hits that shouldn't have penetrated. The prisoners were confused. The Tiger's armor had done its job. The shells hadn't penetrated. So, why had the tank burned? The interrogators filed reports. Something unusual was happening with American anti-tank tactics. The Germans were reporting higher Tiger losses than expected. Many to fires rather than penetration. The pattern suggested a vulnerability, but no one could articulate exactly what it was. This mystery would persist through the end of the war and into the immediate post-war period. American ordnance specialists would examine knocked-out Tigers, looking for penetrations, trying to understand how their 75mm guns could have destroyed these heavily armored tanks. They found Tigers with minimal exterior damage, but completely burned-out interiors. They found Tigers with jammed turret rings and phosphorus residue on the engine deck. They found Tigers abandoned by their crews with no apparent combat damage at all. The full picture wouldn't emerge until captured German technical documents were translated and analyzed, and post-war interviews with surviving German engineers revealed the ventilation system vulnerability. Only then did American tankers understand that their improvised white phosphorus tactic had accidentally exploited a fundamental design flaw in Germany's most fearsome tank. But before that understanding came, there were the battles themselves. The desperate, close-range engagements where theory met steel and men died testing tactics that barely worked. The places where white phosphorus went from experimental nuisance to standard procedure, not because anyone ordered it, but because tank crews who used it lived and those who didn't often died. One of those places was Normandy in the summer of 1944, where American armor met German Tigers in terrain that turned every advantage the Tiger possessed into a liability. The hedgerow country, the bocage, where visibility dropped to a few hundred meters and combat happened at ranges where even 75mm guns could threaten German armor if the crew was skilled and lucky. Staff Sergeant Lafayette Poole commanded Sherman No. in the Mood with Company I, 3rd Armored Division. By late July 1944, Poole had established a reputation. His crew had knocked out 12 German tanks, mostly Panzer IVs and Panthers. They'd survived 6 weeks of hedgerow fighting through tactics that boiled down to aggression and accuracy. Get close, shoot first, shoot straight. On July 27th, Poole's platoon was supporting infantry near Saint-Lô when they encountered 2 Tigers from the 501st Heavy Panzer Battalion. The engagement happened at 400 meters, close range for a Tiger, but still outside the effective penetration distance for Poole's 75mm gun against frontal armor. Poole's gunner, Corporal Wilbert Richards, fired first, white phosphorus. The round struck the lead Tiger's turret face and detonated in the characteristic white bloom. Within seconds, the Tiger was engulfed. Richards loaded armor-piercing. Poole traversed left, looking for the second Tiger, which had reversed behind a hedgerow. The first Tiger sat in the road, smoke pouring from every opening. Its turret traverse stopped. The crew didn't bail out immediately, which suggested they were still inside, still trying to fight, but blind. Poole ordered his driver to advance, keeping the burning Tiger between his Sherman and where he thought the second Tiger was hiding. They closed to 200 meters. The Tiger's engine was still running. Poole could hear it. Then flame erupted from the engine deck. Not phosphorus smoke, but actual fire. Orange flames, oil smoke, the unmistakable signature of an internal fire. The Tiger crew bailed out. 4 men, then the 5th. They ran from the burning tank without weapons, without looking back. Poole's gunner tracked them, but Poole ordered hold fire. Let them go. The tank was dead. That's what mattered. The second Tiger never reappeared. Post-battle intelligence suggested it had withdrawn after seeing the first Tiger burn. 1 engagement, 1 white phosphorus round, 1 Tiger kill. The mathematics were better than anyone had expected. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Pool's crew filed their after-action report. One Tiger destroyed by fire after white phosphorus hit. The report noted that armor-piercing rounds were never fired at the target. The white phosphorus round had done the job alone. Similar reports were coming from across the Normandy front. Tigers burning after white phosphorus hits. Tigers abandoned after white phosphorus engagements. The pattern was undeniable, but the mechanism remained unclear. German commanders noticed it too, but from a different angle. The 501st Heavy Panzer Battalion's war diary for late July 1944 includes increasingly frustrated entries about Tiger losses, not from penetrations, not from mechanical breakdowns, but from fires. Internal fires that started after what should have been non-threatening hits. One entry, dated July 30th, describes Tiger number 234 abandoned by its crew after taking 2 hits from what the battalion intelligence officer identified as smoke rounds. Post-recovery inspection showed minimal exterior damage. The turret ring was jammed by impact shock, certainly, but the real damage was inside. The entire engine compartment had burned. Fuel lines melted. Electrical wiring destroyed. Ammunition partially cooked off. The intelligence officer concluded that enemy smoke rounds had somehow penetrated the ventilation system and ignited fuel vapors. He recommended that crews be instructed to shut down ventilation fans immediately upon taking smoke round hits. The recommendation was never formalized into doctrine. By early August, the 501st was being withdrawn from Normandy down to fewer than 10 operational Tigers. Back at Zosen, where Zimmermann had stood months earlier tracking Allied armies that didn't exist, German intelligence officers were compiling reports from Normandy. The Tiger, which had entered the war as Germany's ultimate armored weapon, was proving vulnerable in ways no one had anticipated. Not from American tank guns, which still couldn't reliably penetrate frontal armor, not from mechanical failures, though those were constant. From fire, from internal fires that started after hits that shouldn't have been catastrophic. One report, compiled in August by the Ordnance Department, attempted to analyze the phenomenon. It noted that American forces had begun using smoke rounds as direct-fire weapons against German armor. The report speculated that these rounds contained some form of incendiary material that could ignite fuel or lubricants. It recommended additional fire suppression equipment be installed in all Tigers still in production. But the report never identified the specific vulnerability. It didn't mention the ventilation system pulling burning particles into the engine compartment. It didn't note that the unprotected fuel lines provided ignition points throughout the engine space. It didn't recognize that the Tiger's design, optimized for armor protection, had created a perfect environment for phosphorus-fed fires to spread uncontrollably. This information gap meant that Tiger crews continued fighting without understanding the specific threat they faced. Training manuals weren't updated, tactics weren't adjusted. The crews did what they'd been trained to do, maintaining ventilation during combat, keeping engines running, fighting their tanks by the book, and they kept burning. In September 1944, American forces were pushing toward the German border. Tiger battalions that had survived Normandy were being reconstituted, receiving replacement tanks and crews. The new crews received the same training as their predecessors, the same doctrine about armor invulnerability, the same confidence in the Tiger's technical superiority. They received no warnings about white phosphorus, no briefings on the specific vulnerability, no tactical guidance on how to counter this threat. The institutional knowledge was there, scattered through battalion war diaries and intelligence reports, but it never became operational doctrine. Lieutenant Wilhelm Schultz took command of Tiger No. 417 in early September 1944. His battalion, the 509th Heavy Panzer Battalion, was being reformed in Germany after losing most of its equipment in France. Schultz was 22 years old, trained at the Paderborn Tank School, confident in his abilities and his equipment. His training had emphasized the Tiger's strengths, the 88mm gun that could kill any Allied tank at ranges exceeding 2 kilometers, the armor that made the Tiger essentially immune to frontal attack, the prestige of commanding Germany's most powerful weapon. His training had said nothing about white phosphorus, nothing about ventilation system vulnerabilities, nothing about the Americans' evolving tactics. He was being sent to fight a war his training hadn't prepared him for, in a tank whose weaknesses he didn't understand. By October 1944, American intelligence officers had accumulated enough data to understand that something unusual was happening with German tank losses. Interrogation reports from captured crews mentioned fires repeatedly, internal fires, unexplained fires, fires that started after hits that seemed minor. One interrogation, conducted in late October, involved a crew from the 503rd Heavy Panzer Battalion captured near Aachen. The tank commander, an Oberscharführer who'd been fighting since Tunisia, described his Tiger catching fire after being hit by what he called a smoke round. The round had struck his tank's side armor and detonated without penetrating. Standard smoke generation, he said, nothing that should have damaged the tank, but within minutes the engine compartment was burning. The fire spread so fast his crew barely had time to bail out. He'd lost 2 men, the loader and radio operator, who'd been overcome by smoke before they could escape. The interrogator asked if this had happened before. The Oberscharführer said yes, multiple times. He'd seen other Tigers burn the same way. Smoke round hits followed by internal fires. The crews had theories. Maybe the Americans were using some kind of special incendiary round. Maybe there was a fault in the Tiger's design. Nobody knew for certain. The interrogation report was filed with hundreds of others. The pattern was noted, but not analyzed in depth. American intelligence was focused on German troop movements, on identifying units and assessing strength. The specific mechanism of how white phosphorus was killing Tigers was interesting, but not immediately relevant to operational planning. The answer was there, scattered through various reports and technical documents. American ordnance specialists knew that the M64 round contained white phosphorus. They knew phosphorus burned at high temperatures and produced dense smoke. They knew that the smoke could enter enclosed spaces through ventilation systems. German technical documents, captured in small numbers, described the Tiger's ventilation layout. But nobody connected these pieces. Nobody realized that American tank crews had accidentally discovered a critical vulnerability, had developed tactics to exploit it, and were routinely destroying Tigers using ammunition that wasn't even designed as an anti-tank weapon. The realization would come, but not until after the war. Not until German engineers could be interviewed at length, not until captured Tigers could be examined thoroughly, not until the full technical documentation could be translated and analyzed. In the meantime, the pattern continued. American tanks engaged Tigers with white phosphorus. Tigers burned. German crews died or bailed out. After-action reports noted the kills. Intelligence officers compiled statistics. The war ground forward. In November 1944, Lieutenant Schultz and Tiger 417 were sent to the Ardennes, where German forces were preparing for what would become the Battle of the Bulge. The 509th Heavy Panzer Battalion had been rebuilt to something approaching full strength. 43 Tigers, organized into 3 companies, attached to the 6th Panzer Army. Schultz's crew was experienced by this point. They'd fought through several engagements during the retreat through France. They'd learned terrain tactics, learned to use buildings and forests for cover, learned that American tanks were more dangerous than training had suggested. But they still believed in their armor, still believed the Tiger was fundamentally superior to anything the Americans fielded. The offensive began on December 16th. For the first few days, the Tigers performed as designed. In the narrow forest roads of the Ardennes, where engagement ranges dropped to a few hundred meters, the Tiger's armor was still decisive. American tanks couldn't penetrate frontally. The Tigers killed Shermans systematically. But then the weather cleared, American aircraft returned, and the Tigers, concentrated on narrow roads, became targets, not from bombs, not primarily, but from artillery. High explosive rounds that didn't penetrate armor, but disabled tracks, jammed turret rings, and killed exposed crew members. And when American armor counterattacked, they came with white phosphorus, Schultz's first encounter with phosphorus came on December 21st near Stavelot. His Tiger was hull down behind a stone wall, engaging American tanks advancing up the road. His gunner had destroyed 2 Shermans and damaged a third when the phosphorus rounds started landing. The first one missed, exploding against the wall 5 meters to the left. The smoke was immediate and thick white clouds that obscured everything. The second round hit turret side, just below the commander's cupola. The explosion was violent, but didn't penetrate. A standard smoke round, Schultz thought. Annoying, but not dangerous. Then, the ventilation system pulled the smoke inside. The fighting compartment filled with white opacity. Schultz couldn't see his gunner, couldn't see the instruments, couldn't see anything. The temperature climbed. His eyes started burning. His throat closed. He heard his loader coughing, heard his driver shouting something about not being able to see. Schultz ordered all fans off. The smoke slowly cleared, but now the engine was overheating. The temperature gauge climbed into the red zone. He had maybe 2 minutes before the engine would seize. 2 minutes to decide whether to abandon a perfectly functional tank because of smoke. He ordered the driver to reverse, to get behind the ridgeline where the smoke wouldn't be as thick. The Tiger moved backward 50 meters. The smoke began to thin. Schultz ordered fans back on just enough to keep the engine from overheating. The compartment cleared slowly. They'd survived. But Schultz understood something now that his training hadn't taught him. The Americans had a weapon that could neutralize a Tiger without penetrating its armor. That could turn the Tiger's ventilation system, its enclosed fighting compartment, into liabilities. That could force a crew to choose between abandoning their tank or dying from smoke inhalation. His Tiger hadn't burned. Not that day. But 2 others from his battalion did. Both from his company, both reported catching fire after smoke round hits. The crews got out. The tanks burned to the frame. Post-battle recovery found them completely destroyed, ammunition cooked off, everything inside melted or burned. The 509th's commander submitted a report. Tigers were being lost to some form of incendiary ammunition. He recommended immediate investigation and development of countermeasures. The report went up the chain of command and vanished into the chaos of Germany's collapsing war effort. By January 1945, the Bulge offensive had failed. German forces were retreating. The 509th Heavy Panzer Battalion had lost 38 of its 43 Tigers, some to mechanical failure, some to air attack, some to tank destroyer fire, but a significant number, perhaps a third, to fire, following smoke round hits. Schultz survived. His Tiger was finally knocked out by artillery fire that broke a track and killed his driver. He and the remaining crew abandoned the tank and withdrew on foot. He never commanded another Tiger. By war's end, he was fighting as infantry, defending some nameless village against American forces that had more tanks, more artillery, more everything than he'd imagined possible. In his post-war interrogation, conducted in June 1945, Schultz described his experiences fighting in a Tiger. The interrogator asked about specific losses. How many Tigers had he seen destroyed? By what weapons? Schultz mentioned the fires, multiple Tigers burning after being hit by smoke rounds. He didn't understand it. The rounds didn't penetrate. The tanks should have been fine, but they burned anyway. The interrogator made notes. The pattern was familiar by now. Captured German tankers consistently mentioned Tigers burning after smoke round hits. The mechanism was becoming clearer as more technical documents were captured and translated. The vulnerability was real, significant, and had never been addressed by German design teams. American ordnance specialists, finally able to examine captured Tigers in detail, confirmed the vulnerability. They tested the ventilation system, measured airflow through radiator grills, traced the path that smoke would take from exterior to interior. They ignited phosphorus outside a captured Tiger and watched the ventilation fans pull the burning particles through the engine compartment. The conclusion was undeniable. The Tiger's ventilation system, designed to keep the powerful Maybach engine cool, created a direct path for white phosphorus to enter the tank. The burning particles would settle on hot engine components, on fuel lines, on electrical systems. Fires would start in multiple locations simultaneously, spreading faster than any fire suppression equipment could handle. The vulnerability was fundamental to the Tiger's design. Fixing it would have required a complete redesign of the engine cooling system, which would have meant redesigning the entire tank. Germany never had the time or resources to do this. The Tigers that fought through 1945 carried the same vulnerability as the Tigers that fought in Tunisia in 1943. The difference was that by 1945, American tankers knew how to exploit it. White phosphorus was standard ammunition in every Sherman that faced German armor. The tactics were refined. Fire phosphorus first, blind the target, force the crew to choose between suffocation and abandonment, then close for the kill with armor-piercing rounds. Post-war analysis suggested that white phosphorus tactics accounted for a significant percentage of Tiger losses in the final year of the war. Exact numbers are difficult to establish because many battle reports simply listed tanks as destroyed by fire without specifying the cause, but German unit records, when cross-referenced with American after-action reports, show a pattern. Tigers engaged with phosphorus, Tigers burning, Tigers abandoned. The irony was that the Tiger's greatest strength, its thick armor, created the conditions for this vulnerability. The armor that made penetration so difficult also made the fighting compartment a sealed environment. When that environment filled with smoke, the crew had nowhere to go. They couldn't fight from outside the tank. They either stayed inside and suffered or abandoned the tank and lived. American tankers hadn't planned this. They'd discovered it through desperate improvisation, refined it through trial and error, and standardized it because it worked. The M64 white phosphorus round, designed for artillery spotting, became one of the most effective anti-tank weapons of the war, not because it could penetrate armor, but because it didn't have to. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.